to episode 3, and I just wanted to introduce a little bit about the cyber riskers community before we start. So the cyber riskers community started in Sydney in 2017, and we are now over 3,000 members strong across Australia, Singapore, and Japan. And more recently, we've been connecting with you through a series of virtual webinars. So today I'm really proud to introduce our guest speaker. Our guest speaker, Dean Houari, is head of DevSecOps for Asia Pacific at Checkpoint Software, and he leads the architecture and strategy for DevSecOps for cloud and cloud native security for Checkpoint solutions with open source forums. He has over 20 years of experience at F5 and Cisco, and holds a patent in the Cisco switching architecture. He's also an avid powerlifter with a total of 660 kilograms. That is freaking massive, Dean. That's squat, bench press, and deadlift, right? 660 kilograms.
All right.
Yeah, so by comparison, my squat, bench press, and deadlift is less than half of that, around 320, I believe.
That's pretty,
so let's get into today's topic. Shift left security, the shift of code-centric cybersecurity. Can you explain what shift left security means and why today's topic is so important for the audience?
All right, thanks, Stephen. Appreciate it. It's good to be part of Cyber Risk. I guess you guys have a solid reputation. Let's, yeah. So I'm gonna basically today. There's only 40 minutes, so if you're gonna have to indulge me, I'll just go over the whole strategy. From our perspective, I don't think there's time to dive into each area of securing the elements of DevOps and obviously shifting the security to the left. So we'll just explain what is the strategy, what are the fundamentals, and the areas that needs to be covered. And hopefully I can get your questions. All right, let's see. All right, so some of you may be application developers, some of you may be infrastructure or security operators. I think there is a shift that is taking place, but that is definitely towards software. Obviously, as you all know, every company, whether they've been traditionally building hardware, switches or firewalls, or everybody's moving to software. The integration with the move to the cloud and the start using cloud native operation, which I'll kind of cover in a bit. It's important to understand what software means and how applications are actually developed. I understand this whole concept of DevOps. I think it's a very important place to start, especially if you're not an application developer and been more on the network infrastructure side and even security operational side. So because that's basically the mode of operation that everybody's going to have to adopt. As the title mentioned, DevSecOps, I mean, obviously you're inserting the security into the DevOps in the middle, right? So it's very important to see, if you don't understand what DevOps is and what it's all about, it's going to be very hard for you to understand how to secure all that. Thus said, essentially, this is what it is. This is the life cycle of an application. Typically, you have an application that needs to be built, and as you know now, today there's a huge proliferation of applications, and it's usually you have a team of programmers that are focused on a feature as part of the application that basically writes the code for that feature. And the way it works is eventually every programmer that's working on an application will basically kind of save their code into a central location, typically called a repository, essentially a server, in a certain branch, which is essentially a version of code for that application that will eventually be merged into the whole application code base, which is the application itself. And then obviously that's how the application is born. That is basically the code of the application. Now, to make sure that the application is actually behaving as expected and without any bugs, and before it's deployed to the infrastructure where it's supposed to be accessed by user, there's a compiling and QA testing process that happens. Compiling meaning that the raw code typically cannot be tested into an environment. You need to compile it to an image, or compile it into, or package it into a virtual machine or a container, or now a serverless function. I mean, some some package that could be tested into on an environment. And then you test it, you create different use cases to make sure that there is no bugs in the code, that the application is behaving according to spec, and then once it meets the criteria of deployment, the application team basically hands it off to the infrastructure team and the operational team for them to deploy it. And typically, the traditional cybersecurity has been on this side where once you have the application that you do your security assessment and then you do your pen testing and so forth and then while you're distributing it or before you're distributing it. Obviously, so there is this doesn't sound very automated. This doesn't sound very efficient. If you're producing one application a year, maybe, or a few application a month, that's maybe feasible. But now as companies have to deploy a lot of application all the time and do changes all the time, it's just, this is not, doing this manually is just not manageable. And obviously the rise of DevOps, obviously the merger of the development side with the operational side in order to push code to production as fast as possible and with as many to make the changes as seamless as possible and produce more application. Okay, so DevOps is obviously not just a bunch of technology, not just being the application developer. It's a whole culture, obviously, that is driven around collaborating between the different different players that are involved into creating an application. In this case, the application developers, but it could be also anybody that writes code. So, and as we'll see, because now code applies beyond application, also applies to what we call infrastructure as a code, meaning is if you're deploying your infrastructure using configuration into a code base like JSON or YAML, that applies as code as well. So essentially, it's a matter of everybody committing their code into one place so that it could be reviewed, so it could be shared, it could be merged and then pushed. Now, as I said, efficiency, obviously, what's going to drive efficiency is automation. None of the step, which is committing, compiling, testing, feedback in case there is any bug or whatever, should be fully automated, because otherwise it's all manual. They will take way too much time and actually cost you a lot of money. This will be a very expensive proposition. And obviously, and thus with the automation and making it as efficient as possible to be repeatable. Like instead of having a proprietary model, we have a kind of a like a template-based type model where you can just repeat it over and over, which is more efficient. And the ability to get feedback, so you can measure what you've done, how well you've done it, to make it even out, to refine your process for the application deployment, development and deployment, and whatever you've learned, share it. And this is why you have concept of shared repositories like GitHub, and which I'll explain, that basically where you can go and see other people's work and comment on people's work, kind of like the social media of developers. Sharing is very important. So you have this comms model that needs to be understood, and you can see that the DevOps culture. So learning to be part of DevOps is beyond just learning DevOps tools and learning automation. It's about really having this culture to do the automation and the testing and everything while having this culture of sharing and collaborating with everybody else. And this is unique to application development. This is really foreign to infrastructure typically, where infrastructure is very silo-based. The network teams will not talk to the compute team, will not talk to the operation team. They won't even barely talk to the application team. They speak different languages. So, I mean, there has to be a transformation. Adopting this model is beyond just adopting the tools, it's adopting the culture. And if you want to kind of like, still doesn't make any sense to you and don't understand what happens, just look at how the other manufacturing industry, because it is essentially you manufacturing applications. So in the same car, like in the car industry and the other industries that to make them more efficient, leaner, to reduce the cost to produce anything that they produce, is essentially moving from manual production to assembly line type. So look at DevOps in the same angle, like instead of manually producing your application, kind of like custom production, you have an assembly line of application development where you just use kind of like pre-made components that can be just added and removed as needed, kind of like with dedicated stages within the application development that are managed by different users, but as part of the whole assembly chain. So this is how you can achieve this continuous automation. So this is one way of looking at it. So let's look at the different concepts that are key. One of the key concepts of DevOps is source code management. As you know, you need code to start. This is where it starts. And this is, actually, I forgot to mention something. Thank you for reminding me. From a security perspective, since today is about shift left security, to illustrate what shift left means in a few words. As you can see, security is here has been usually applied once the application is deployed into the production environment. But obviously with DevOps, what's going to happen is that that's not going to work anymore, because if the code is compromised before to build an application, then the application that you deployment has already compromised code in it, meaning is could have some malware in it. So it's important to, so far the security has been done on the right-hand side, the distribution and install side. So it's important to move your security towards the programmer side, all the way to the time he's committing his code to a code base. That's what it means by shifting the security to the left. Okay, just to note that. So
And
let's
that's
understand.
really interesting. That's really
Sure.
interesting as well, because I think, if you think about pulling templates from places like GitHub, I'm trying to recall. I think there was a story with British Airways where they were exploited because they pulled in I think from some repository lines of malware. I think there was like 17 lines of bad JavaScript which stole customer information through the payments portal. I think if they had something like this in place, or automated check, is that something they would have been able to discover beforehand, before releasing the update?
Absolutely. You just nailed it. I mean, this is a threat. I mean, and this is I mean, think about it. I mean, isn't that a better way of hacking somebody's environment? I mean, traditionally, if somebody wanted to attack you, well, still today, he will have to somehow attack your firewall, trying to breach your environment. That takes a lot of work and effort and resource and patience. Maybe crack some passwords to steal your credential, or send you some phishing email. It takes a lot of work, and then you get in, and then you're trying to find a way of installing malware, and then you have to face more security, like a WAF or some host agent security. That's a lot of work. Whereas inserting, posting some malware in, inside of a code file on a repo, shared repo like GitHub, having that company developers use it, it's kind of like they're doing all the work for you. So they're deploying an application for you with your malware. They can easily trigger at a later stage. I mean, that's like, might as well, it's kind of like do the work for me, and then you could just later on
It's
do
like
whatever you want,
it's like
So yeah,
automated hacking, right?
attack.
So
So you're,
automated attacks. So, do you feel like more and more companies are looking towards central repositories for them to save time, so they don't have to build code from scratch. They can take something that's existing.
actually, I'll cover that. I think that this is
Sure.
a consequence of DevOps. It's not so much
Got it.
that they want to use stuff. I mean, you know what? It just kind of like look at it from. That's why I like to use the car example, because when you have an assembly line that is moving at a fast pace, you don't have time to make custom parts. You have to get a part from some other vendor, right? And the same thing, you don't have time to code anymore, so you get your code from somewhere where there's typically a shared repository, because that's how developer works. Like DevOps is about sharing. Same thing, if you have a car, they're gonna get a part of the engine from some manufacturer, and if that part of the engine is defected, eventually the engine will break, right? Because some of the part is defected. And you can see that whether it's making planes, sometimes they found a plane crashed because some screw was made out of aluminum instead of made of titanium. And this is the same thing, right? And eventually it crashes, like, what happened? And they look at the screws, it just broke. So the same thing is now because of this automation in DevOps, and the fact that everything has to be repeatable and template based, they start importing. They need to import stuff from. You have no choice. No coder today will build everything from scratch for himself. There's just no time, sometimes not even knowledge to do that anymore, and thus introducing potential security vectors or malicious vectors into your code. that then in turn could be an exploitable threat in your application that so you're deploying it for them. They don't have to kind of brute force themselves or steal credential to get into your environment. You're deploying it, their malware for you. And you have to ask yourself questions. You look at it. Sorry, I'm diverging a bit, but it doesn't make sense. It's the same thing. You ask yourself, like sometimes you hear about big hacks into banks and nuclear plants and critical infrastructure and government sites, and like these guys sometimes are not even connected to the internet. How do they get into the environment in the first place? Is via code. Most of when you hear about North Korea hacking and you hear about Russia hacking and the NSA and all that stuff, you're like, man, these guys have to be super hacker. You see these movies and they're like typing a password or like, oh, I got in. It doesn't work that way. It's basically typically via the application that nuclear plants or critical infrastructure or voting systems are using that get infested with malware or some kind of underlying malicious vector that can be exploited later stage via HTTP or via trigger or phone call, whatever. So this is the this is how it is. I mean, but this is why this is becoming so important. Now, you're gonna ask me is like, so this application there is no security? Yes, there is security. The application developer do have security tools, and I'll look at that. It's just not adequate. Like your security is as good as what you can detect, right? So if you have a malware that the security tool that you're using is not able to find, which is typical because it doesn't have the threat intelligence to do that, then you will say I'm safe, but you're not really. And so this is what we're dealing with. So let me just go back to thanks for the very good question. Thing is just for those of you that don't know what a repository is, because I know that infrastructure does not use repository, does not share. So it's just these SaaS-based type website where you could upload your files and your code, and then that it's kind of like a social media, like the Facebook, like a Facebook. And the biggest one is GitHub, obviously. But you also have Bitbucket and AWS Code Commit. You have a bunch of them, but the one that is kind of like the Facebook of the code is GitHub. Personally, I use GitHub. Everybody uses GitHub. And this is where anybody could create an account, post their stuff there. So we will say, for web application, it will just say, this is one piece of code that make this feature do this. So if I'm trying to write a web application and I'm trying to create a shopping cart, and I don't know how to write a shopping cart code runtime for it. I'm gonna go on GitHub and look for shopping cart, and then this is great. So I'll just import that and include it into my code. Branches is typically the version of the code you're using. Obviously, code have different version. Meaning is you do want to have a stable version that is bug free or close to bug free, and then any new feature, any bug fixes, anything that is added, you add to another branch because you don't want to compromise the stability of the code. So this is versioning and branches and repository is something that everybody needs to do and learn. Okay. The other concept is this concept of immutability. Typically that DevOps and cloud introduces. Typically in data center and infrastructure today, if you have switches and you have firewalls and you have servers and everything else, and if because of load increase or user number increase or application demand increases or changes, you typically just try to fix the server or the appliance that you have, right? Even virtual, you add more vCPUs, you add more memory, you add more cores, you add bigger hard drives. Kind of you treat your devices as pets. You're trying to fix them rather than replace them with something new. Sometimes you do, but most likely that's what it is. Cloud is different. Cloud is more immutable. Is once you deploy a server in a container or function or a virtual machine, basically if it doesn't have the spec, what you do, you just add another one with this concept of auto scaling that is native to the cloud. So yeah, this is the pet type mentality does not work with DevOps. DevOps is demand changes all the time. If I need more, just add more. If it doesn't work, just destroy it and nuke it and replace it. So this is something that is important to understand. So next is how the stuff coming in, as Steven mentioned, that happened also with Uber. because it's not always malware. It's just as easy as because you leaving your username and password into the code. As you know, with DevOps, obviously, as you can see in the picture that I gave you, there's a need of integrating a lot of tools, because there's a tool to do commit, there's a tool to compile, there's a tool to test, and the way it's integrated is using APIs. And this is because that's how application integrates with anything else, is using APIs. And what happens is either they use a username password to authenticate the tool, to have access to the tool because of licenses and other requirements, or they use API keys. And if you don't want to encrypt those keys and save them into a location and use them as environment variables, what developers do, they just write the username and password API key in their code. And then they upload that to GitHub. And what happens? Somebody finds those keys, and then they go and breach your environment. And that's his basic. So it's just beyond just malware. So essentially, you go to GitHub, they get their code for GitHub, they Google for it. I'm looking for this piece of code that does that. They go to GitHub, they do a search, they find one, they download it. They don't care whether the user that wrote that code was a hacker or a government or malicious or non-malicious. They don't feel that's part of their job. They just import the code in their function and use it for the application. And this is what happens. GitHub now is making an effort to introduce scanners into the GitHub. If you go to GitHub these days, there's an option to scan your code. But once again, that's just kind of like a band-aid. It's not really, it's just giving you this false sense of safety. I mean, GitHub officially told the press, listen, I mean, it's just like Facebook and the fake news situation. They're not responsible for the content that they're hosting, okay? So you do your own, that's the responsibility of the user that is using the content that they're downloading, okay? So that is pretty clear. All right, so I hope that cleared this new world of different type of attacks. I mean, there was Uber, so basically this is the thing with Uber, where basically this obviously some developers uploaded their code to GitHub and they left the username and password. They used that username and password to hijack their environment by locking them out, and obviously ask for a ransom. They paid $1 million or a few millions, and to keep it out of the press. And say it happens at Bank of America. This stuff is happening all the time. You just don't hear about it. All right. It's getting worse because now, before typically it was a physical server and virtual machine to host your application, and typically you had an operating system that you could secure the code that because it's running on a virtual machine runs on an operating system. But now, as with DevOps, that doesn't work anymore. It's kind of using code-centric type servers because everything needs to be as a code to be integrated into a DevOps pipeline, and thus the rise of the use of containers and serverless. So if you wonder why containers and serverless are becoming a hot thing in the cloud or on-premise, this is why, because containers can be deployed with a code template very easily. They're not based on any operating system. They're very portable. They can run on any environment without any refactoring or rewriting of the code. I mean, if you have a VM and you develop your application on a VM that is running on Windows, and that application, then if you could not just take that application running on Linux or run it on AWS Linux or Azure Linux. You need to redevelop the application or refactor the application. There's no portability into that, right? So with containers and serverless, you don't have to do that. And this is why now the definition of a workload itself is changing in that sense. And serverless, obviously, there's just no server anymore. All you're managing is your code and runtime, and they're natively designed to have this abstraction of the infrastructure. With containers and serverless, you don't have to worry about on which server it's running, on which network it's running. There is complete abstraction on the underlying infrastructure that basically application developers wants to do. Application developers do not want to deal with subnets and VLANs and access lists and all that stuff, even firewalls. Well, they just want to deal. I just want to run my workload, and this way, and add security as code if I have to, as part of my code that I'm checking in, and that's as far I want to know. I don't want to know anything else. And so that's why security are changing. The workload type is changing. Now, there are challenges with using these type of workload type, which container and serverless. as you've used containers, containers is not a lighter virtual machine, a smaller virtual machine. A virtual machine virtualizes the operating system. A container virtualizes the kernel. If you're familiar with Linux, it's kind of evolving from the concept of user space in Linux. Same thing. They just add more features with the Docker and other runtime, but essentially that's the same thing. So a VM is not a container, or a container is not a lighter VM. Just keep that in mind. All right, there's a huge change. Typically with a VM, you have an IP address that is attached to it. With container, there is no IP address. Essentially, you share an IP address and you get assigned a random port. And that basically, and a container does not run forever. Once the task of the container is in the code that is defined is finished, the container is killed, just like a process. So it's so to speak, it's ephemeral. It's not designed to be there forever, and there's no lasting IP. So how do you secure that without knowing an IP, right? I mean, so it is challenging for the security team, and thus the rise of microservices, where in VM you have basically one big application that has all the tiers, maybe the web front, the front end, and the back end, and the database, and so forth. Whereas containers, you can basically distribute all the front end and the back end into different containers, and thus the terminology of micro, because container is small, and services, so all the services are distributed, interconnected. This is microservices, and you can basically integrate them into a DevOps pipeline, so you can do changes fully automated at the speed of a DevOps. So there's a knowledge gap from the security team, the knowledge, understanding containers, and from the infrastructure team. This is a huge challenge of moving to using this type of workload. It gets worse with serverless. Serverless, basically, now you don't even see the servers anymore. The servers are owned and managed by the cloud provider, like AWS. All you do is run code and use APIs to run your application in the cloud. So you're moving from using virtual machine and servers and even containers to piece of code and APIs. Like a function is essentially a few lines of code that you natively run on the cloud, in the cloud infrastructure. So now we're talking not micro, we're talking about nano services, because they're even smaller, right? And basically, so all you have to do to change your application, you have a programmer add a line to code, remove a line of code, push it, and then you have a new function that will deploy onto your environment. So security-wise, how do you deal with this? How do I have visibility on what's going on? How can I apply a new security policy every time there's a change? And you understand with serverless, I don't know if you use Alexa or other serverless-driven type application. It's kind of like trigger-based, right? It doesn't stay there forever. It kind of starts only when you invoke it, meaning, Alexa, what's the time? And Alexa will then wake up and then go to a server and then say to fetch the data of the time of the day, and then reply to you, it's 10 a.m. or 12 p.m., right? And then you can ask a different question, like, what's the weather? So you can invoke the same function with different triggers, and each triggers may require different security policies. So as you can see, the traditional security does not work anymore. You need a code-centric cloud security. This is why this is kind of taking place. It's not just because it's cool or because it's just DevOps. It's because containers and serverless requires it. Okay, which are becoming the new type of workload into the now to the how application are run. There is motivation from businesses why they want to move to this kind of workloads. You pay only for what you use. Virtual machine server, you have to pay for it's on all the time, right, to run your applications. That takes electricity, capacity, rack space, and all that stuff. Here, these things don't do it. It's all software. It runs, it stops. That's all you pay for. You can deploy them right in seconds instead of like calling the IT team. Can I have a server? And it takes me a week. I mean, so and it's just small piece of code, and you can deploy right away into your environment. I should have shown this earlier. I need to wrap up, but this is what DevOps pipeline looks like. It kind of aligns itself with the picture I gave you on how to make an application. Typically, there's 4 main stages, which is committing the code, compiling it to an artifact, which is an image or container or function, or even a virtual machine if you want to, but that's not the usual way. And then testing it and deploying it. So you have these 4 phases. So from a DevSecOps perspective, where does a sec come in? Is inserting the security between these stages. There could be more stages, of course, but this is the foundation, this is the minimum. So when you go to the container, which is managed by the CNCF, which is the cloud native open source framework, it gives you what they call the 4 C's of cloud native security. This is on the Kubernetes website. And it aligns itself with this picture, right? It starts with securing your code that you use package into a container. So now you have to secure the container that you deploy into a Kubernetes cluster. That's your infrastructure. That you deploy into a cloud data center or a colo. That's the underlying infrastructure. So each of these steps need to be secure. Just that falls in line of the DevOps pipeline, right? So to understand how security works here is how do I secure my code makes sense. You have a piece of code, so you need to something that can parse the code and look for malicious vectors, like Stephen mentioned, some line of malwares or some username and password or an API key and so forth. So there's this what we call the static scanning, static application security testing. You scan the code with code scanners, or code meaning source code, or it could be a infrastructure as a code template like Terraform or Ansible or CloudFormation templates from AWS or Azure ARM templates. It's a template written in JSON, so it's code essentially. You have to scan container images, functions. So you have to make sure that you go parse that code and then analyze it with some threat intelligence engine where that's to identify malware or unknown, identify CVEs, vulnerabilities, and so forth. Something that has that database to say this code is good to use or not good to use, or this container image is safe to use or not. This is static application testing. This is how you insert that first phase of security. Governance is more to the cloud, meaning is, as you know, when you go to the cloud, even if you work for a bank or wherever, you could, if you want a virtual machine or container, you could do it yourself. You don't have to call IT to do that for you. As long as you have an IAM account, you can configure your own server. And the problem is since you're not a expert anymore, you just could be a finance dude or an HR or business that has no clue about technology, but you know how to go to a GUI and say, click, I want a server or container, whatever, or I just want a hard drive or a bucket. It basically, you don't know how to secure it. Securing something in the cloud requires proper roles, permissions. So the default is always very permissive. That can be also exploited. So that's the static one. And then the dynamic one is once you deploy your application in a container and a function into production, then this is what we call runtime security. So meaning is while the application is running, detect attacks. Typically, I don't have time to explain. There's attacks that are like OWASP, the web attacks that are known, like code injection, script code, API attacks, and so forth. There's a whole list of them. You look at the behavior. If you have a crypto mining malware, are you spinning more containers to run your crypto mining activities, or are you running more spawning a new process to then steal data from a database and so forth? So there's this what we call this analysis of the behavior, and then you can say this behavior is allowed or not, and you can block it accordingly. To look at from this perspective in closing, this is the static part. You scan the code, you scan the templates that are being used that are written in code. You scan the container and once they're compiled into a package, and then you do more scanning when they're being tested. One example of a pipeline that I like to demo, I have a GitHub page, and I think we'll share the link, this is typically how DevOps is with security. The cat there is GitHub. This is your source code management. So you push your templates to there, you push your code. So you have a scanner that is as part of the pipeline that is fully automated. As soon as it detects code being saved, it will start scanning that. And then once you say this is good enough to pass, then you use that code to be compiled into a Docker image. And then you scan that image because Docker image are using external images outside of your control. If you know how to build containers, that you scan before deploying into a registry where you store your images or to your infrastructure on a Kubernetes cluster. Jenkins is the famous open source CI/CD management server. So the whole pipeline is created on Jenkins, but it could be also Bamboo or CI server or AWS code pipeline. There's a myriad of them. Finally, I don't know, I think I have to close this, but finally, basically, this is the overall solution. So if you understand how everything fits in, okay? So you're the security guy, you have the assignment to say, man, I have to secure this DevOps environment. I can't let this application developer do what they want. In a sense, so what do I do? Do I secure the network? What do I do? How everything fits in? Well, Gartner has this framework where it says this is if you want to secure your workloads, this is how you do it, because it's not going to be a tool, it's going to be a combination of different security tools. Okay. And you define them in layers. So layer one, quickly, once again, configuration. Is the configuration of the container, of the function, of the virtual machine, is that secure? Do I have the right permissions? So is the configuration of my infrastructure secure? So this is kind of standard, but more so in the cloud than on premise, because on premise, typically you do the configuration on the behalf of the user. Where in the cloud, any user can configure stuff. So if you don't get a tight leash on the configuration, you're gonna have problem. So this is kind of like securing your posture. The code scanning is what I was explaining essentially. You need to scan the code. Um, why do we scan container images? You're gonna ask me why if you scan the code, isn't my container safe? No, because the way container works are kind of like this layered things that are built upon the kernel. And if your code, which is here at your app, is secure, yes, you say it's secure, but depending on the runtime, it could be Node.js, it could be Python, it could be Ruby, it could be C#. You need to import underlying images to run your code in Node. Meaning is if you're on the Node app, you need Node.js, and the same thing as a virtual machine. And then if you know Node.js, you need either a Linux-based Ubuntu, or you can get a Node container. But these containers like Node.js and Ubuntu, you cannot make them. You have to import them from Docker Hub. It's open source. So typically, people will tend to inject malicious vector in these open source layers and then compromise your application. I mean, typically that's what it is. This is why scanning your code and then scanning the container image is required. Network security is here to stay. You still need to secure the traffic going to your container, going to your Kubernetes cluster, going to your serverless environment. So network security is not going away. If you have firewalls, you're not going to throw them away. You're still going to use them. That knowledge is still critical, but it's part of the layered requirement. It's not. And if you're using the cloud, typically, I don't have time to explain this, but you typically have to architect your cloud into what we call a hub and spoke architecture, where your application are hosted in spoke VNets or VPCs, and your security services in hubs. The internal and external, meaning is to secure the north-south traffic and to secure the east-west traffic between the spokes. Right. This is in line with the cloud security best practices that AWS, Azure, and Google has published last year. Okay. I'm not going to go over this. Layer 3 is runtime security. This is, I mentioned, securing your runtime. So essentially is kind of like before a container runs, looking at the code, you can say this is how the application is supposed to be behaving in terms of what kind of network connection is initiating, what kind of API calls is supposed to be receiving and sending, what kind of processes is supposed to be spawning, what kind of file is supposed to be accessing from the database side, and anything that is outside of that behavior is blocked. Meaning is if it's supposed to be running one process, like, and then it's started spawning another process, like to start another feature or service, that's outside of behavior, just block it. And also block common attacks like zero-day attacks or web code injection attacks and so forth that you get over the API. And so you kind of like constantly dynamically monitor the behavior of your application and a potential attack that could go there. Layer 4 is what we call threat detection. Threat detection is kind of like it's really popular in the tools today. It's kind of behavioral analysis. Essentially, you take the network logs, and then you combine that with the API logs, and then basically look at who's talking to what, and then look at the behavior of from a network topology perspective. This is some of the tool we use at Checkpoint. Essentially, if you're running Kubernetes in the cloud, you can see this source IP is talking to all these Kubernetes worker nodes and services, and then you say, is this guy should not be talking to my ingress node port service, or should not be talking to my ingress service, or should not be talking to my database. So you know, or this source IP is flagged as malicious because it's a known hacker IP with the threat in it. So you kind of like do threat hunting. You look at who's talking to what. If it's normal, it also scan each component to make sure it's not a bot or a malicious actor or a CNC. And then so you can have this ability to kind of detect attacks even before they're happening. Finally, anti-malware scanning. So typically, just to tell you, there's a lot of scanner tools out there, so you have to be careful on the scanner tools. Most of the scanner tools do not scan for malware. All they do is look at what we call a CV database on the NIST, which is the official vulnerability database, and that's it. That's all they do. They don't go as far as doing anti-malware scanning. So you have to look at the tools you're using. Is it looking for what kind of threat intelligence it has on the back end to see if it's scanning for malware, or if it's scanning for CVEs or CWEs and so forth. So the scope of your threat intelligence will define how secure you are. That makes sense. And if you're a security team, an operation team, an infrastructure team, you need to have new best practices to kind of train the application developer team to secure code by doing the static testing dynamic, to start doing their same practices as they do. Security issues should be treated as software issues, not as the old way of using proprietary templates. There should be an API to share them into some kind of central dashboard or something. Deploying infrastructure as a code. Do not deploy firewalls and switches and servers manually or with a proprietary template. Use code. And obviously inserting security controls in the pipeline, as I showed you, and have tools that give you scanners that will give you the proper intelligence to know whether you have malware or not, to know we have malicious vector that could be compromising your application, and do your testing as well as usual with injecting failure. On that, I'm going to pass it back to Stephen to announce the next training. Thank you very much for sticking around and listening.
Sure, thanks. Thank you so much, Dean, for sharing your expertise on that. I think what you've given us is a high-level overview of the landscape for DevSecOps, and I think there'll be lots of questions that follow on from that. So, but just before I announce the next Cyber Riskers webinar, just thought I'd just go through some questions from the audience. So one is, what are your thoughts and challenges regarding decentralized security, which is a common strategy with microservices and compliance standardization in an organization?
Yeah, I mean, as you can see, decentralizing security sounds very good, but I think you need to, even if you do that, you still need to be in charge of the security controls that you're inserting into your microservices. So essentially, it's going to be two, right? You're going to be static application security testing, and then it's going to be dynamic. It's going to be statically scanning the code that is being used to build your microservices, and then scanning the behavior of microservices. So whether the application developers are the one running those tools or not, you need the information fed back to you in a central location in one management plane that will tell you these are the alerts, these are the potential attack, these are the flags that I'm seeing real time. Because the problem with microservices is not knowing the attack, is knowing it in the right time. These microservices are ephemeral. They only last for seconds or minutes as long as the process is supposed to be running. So if you get the alert, if you look at the alert too late, the attack is done. Yes, you can decentralize the security tools by inserting them in the automated processes to deploy microservices, but you still need to have control, a centralized management control on what's happening. Okay.
Got it. And then another question is, have you heard about the risks of serverless due to performance requirements? For example, cold starts versus warm starts as a serverless especially managed containers by AWS, but are short-lived unless you keep them warm, thus having the same risk profile as a long-lived container.
Yeah. So once again, this is a very good question. Thanks, guys. So I think it's like I think that's a very good question. So to answer your question, listen, there's whether it's living for a second or living for a long time and living as a running background process, what's going to secure it is making sure that the code and the container image used to build that container is secure, is free of malicious vector, so that you know that whatever you're deploying is actually safe. Two is monitor its runtime, it's dynamically, so you're constantly monitoring what the container is doing, whether it's lasting for a second or for a minute. If you have that and you have the ability to have that feedback, um, you're fine, okay? But if you don't, then you're gonna have a problem. So whether you let the long, so I wouldn't recommend long live because it's gonna cost you more money. I mean, Fargate and AWS is expensive. So it's implementing the right security strategy in your DevOps environment or container environment that's gonna make a difference.
Got it. Another question is, what is some bad advice people are sharing about DevOps security in the market?
Bad advice?
Yeah, like what's some bad advice that you commonly hear in the market?
Okay, so yeah, this is a good question. So there's lots of, I think it's kind of in line to the same as infrastructure security. They'll tell you either, well, you don't need security, or, the code is safe, my coders don't know what they're doing, or they have scanners already, they're already scanning their tools, or they're using some watermark.
Mhm.
It's always this false sense of security, using a band-aid instead of a padlock, right? So same thing, infrastructure is like, oh, this firewall is good enough, I'm going to be okay, until you get a ransomware and so forth. So it's like, and you're like, how and you hear about breaches from Target, and you have breaches from Capital One. It's like, these are massive organizations that have massive securities. Like, how do they even get breached? It's scope and coverage. They don't have the right tools for the security that they have deployed. So same thing. Make sure it's, yes, you need to just remember, you need two things: static and dynamic, but they're as good as the intelligence behind them. So choosing vendors that allow you to have the intelligence to find malicious vectors like malware or not, this is what will make the difference into your security. So
Mm-hmm. Absolutely. I think you're absolutely right. It's all about the intelligence behind the tools that you're using to support the scanners. What's your advice to some young people that want to learn more about code-centric cybersecurity? What would you recommend for them to do?
well, let's just make it clear. To do code security, you don't need to be a coder. Okay, just make clear, because that's something that scares a lot of people. All you need to do is understand how an application is developed, the stages, where they're committing their stuff, how does it work with the versioning. Understanding the whole culture is key. So I recommend, if you're an infra guy, I recommend a young guy, get familiar with how application developer are working. If you're an application developer, so that get familiar on how you can secure, understanding how that security gets applied into your, they call it tool chain, which is all the tools they need to deploy their application. So if you really want to get to the next step, obviously, is understand how code works, instruct what is a function, and so forth. So get familiar, learn some basic coding, be like JSON or YAML, and take it from there. I mean, but trying to understand security in DevOps without understanding the fundamentals of application development is a no-go. You're not gonna, it's not gonna be beneficial. So that's my recommendation. A long-winded recommendation. Sorry.
So understand the fundamentals of application development.
Absolutely. For me, that's a starting point.
Okay. So just one last question as well. What is the one key takeaway you want the audience to walk away with from this presentation?
DevOps is here to stay. So it's not like you can just put your head in the sand and saying, I'm just going to stick to what I know, regardless of vertical industries. So this is going to be a must learn. Everything is moving to the cloud, whether hybrid or full cloud. So this is also a new reality. The way of doing things in the cloud is different from the traditional infrastructure on-premise way. So I think it is critical to understand this stuff moving on forward. And it's moving fast, right? Like a year ago, you'll say, DevOps, cloud is the future. Not anymore. So just be aware of that. And I think coronavirus has even sped up that process now, with everybody going online and remote work and using cloud and so forth. So as you can see, this is becoming more of an imperative rather than a choice, if you want to be successful in security and in networks and infrastructure and so forth.
Absolutely, absolutely. So DevOps is here to stay. It's our new reality. Just get used to it.
Exactly. Deal with it.
Deal with it. So just one last announcement in terms of our next episode 4, what to expect when running a vulnerability management program, where we will be joined by Robin Bertel on the 8th of July. So please sign up on the webpage. I look forward to seeing you there. And Dean, thank you so much for your time and sharing your insights into this particular area.
Thank you. Appreciate it.
All right. Thank you everyone for your support, for your questions, and for tuning in. I'll see you next time for the next episode. Take care. Bye-bye.
Bye.